Hello everyone. Today we continue the next units of chemistry in PUC second year. We have totally, friends, the 4 topics comes under inorganic chemistry. Yes, in these 4 in inorganic chemistry we have the first one is P block, next one is D and F block. General principle, the coordination compounds, and another one is general principle. These are the 4 allotted topic in our NCERT: P block, D and F block, coordination compounds, and general principles comes under inorganic chemistry. The total weightage of this inorganic chemistry, dear friends, is 28 marks. And this 28 is further divided into P block is 10 mark, D and F is having 8 marks, coordination compounds is having 6 mark, and the general principle here having 4 mark. The question having the weightage of inorganic chemistry is in a part C is totally having 5 questions. They ask 8 questions, 3 from P block, 2 from D and F, and 2 from coordination compounds, and 1 from general principle. This is the first question. It is from your 19th, question number 19, and here this is a question number 20, 21 and 22. This is your question number 23 and 24. This is question number 25 and 26. Yes, sir. These are the questions which are available in inorganic chemistry with some 2 marks question in part B also. So this is a brief introductory part of inorganic chemistry in PUC second year in our NCERT. As we know, friends, in the today's class we started a very important topic of our syllabus is D block elements, or commonly we pronounce D and F block elements, transition metals as well as your lanthanides and actinoids. Yes, the topic D and F block elements. Yes, already we know, friends, this is a very important topic to score well, because the weightage of this chapter is 8 mark. In this 8 mark, the question number 14, question number 23 and question number 24. So the question number 14 having 2 mark, and 23 having 3 mark, and 24 is also having 3 marks. Total, the weightage of this chapter is 8. Dear friends, according to our blueprint, according to our NCERT syllabus, we already know these 2 questions are already known. What are these 2 questions? Yes, sir. Question number 14. Yes, this is regarding to either lanthanides or actinoid contraction. Difference between lanthanides and actinoids, or either what are lanthanides and why it undergoes contraction, what are actinoids and its contraction. There are 3 questions. Question number 14 2 marks ಮಕ್ಕಳೇ. ಕ್ವೆಶ್ಚನ್ ಫಿಕ್ಸ್ ಇದೆ. ಲ್ಯಾಂಥನೈಡ್ ಮತ್ತು ಅದರ ಕಾಂಟ್ರಾಕ್ಷನ್, ಆಕ್ಟಿನೈಡ್ ಮತ್ತು ಅದರ ಕಾಂಟ್ರಾಕ್ಷನ್ ಬಿಟ್ರೆ difference between lanthanides and actinoids question idu compulsory 2 marks more question ide. Question number 23, this is also already we know there are 2 manufactured in the D block elements. The one is K2Cr2O7. I think already know potassium dichromate or either potassium permanganate KMNO4. Either the manufacture of dichromate or either the manufacture of potassium permanganate. The question will be also known. Sir, what we think about this question number 24? Yes, this is also we know, but it is a little lengthy. It is regarding to their corresponding general principles. The various general principles comes under the topic is D block. Either it's atomic size, ionic radii, electronic configuration, or either calculating the magnetic moment, there is a mu value. These are some general principles comes under. And along with this, if you want, sir, why these are having a catalytic property, why they form a complex called as a coordination complex. So these are the different general property. And one more very important general principle of this, general property of this compound is an oxidation state. It's a fixed question, why D block elements are having variable oxidation state. This is the total synopsis of the topic D and F block elements. I repeat, the weightage is 8 marks. Question number 14, 23 and 24. 14 we know, friends, 3 questions. Lanthanide contraction, actinide contraction, or either difference between lanthanide and actinoids. Question number 23 is a fix. The two manufacturers, potassium permanganate and potassium dichromate. Among these fix, they ask one question for 3 marks. If you know already, the 5 marks from this chapter in our annual examination. Little guess with question number 24 also. These are the corresponding general properties comes under D block. Their atomic size, ionic radii, electronic configuration, calculate the magnetic moments. Either the D block elements are having Y catalytic properties, why they form a complex, and oxidation state. So these are the properties we started in this chapter. As this is your synopsis. Okay, let us begin, friends. Very simply, we started this topic as we know in PUC first year. Now PUC first year we consider very simple periodic table. Yes, periodic table is consists of 4 blocks. The first one S block, P block, D block, and the last one is F block elements. Periodic table consists of 4 blocks. The elements are divided into 4 categories: S, P, D, F. We know already in PUC first year is a S block, and little part of P block also we know as the group 2s. Yes, we already know. And PUC second year we have remaining groups is group 15, 16, 17 and 18. And today our target is D as well as F block. Okay, friends, and the D block, where this D block is located, is very important. As we consider, this is our model of the periodic tables. It's a simple. This is our model. And here, in this part we call it the S block, it's a P block, D block, and this is F, consists of lanthanides and actinoids. So where the D block is located? This is a simple 1 mark question. Yes, what is the location of D block? The D block is located in between S and P block. You know, friends, S blocks are nothing but they are electropositive elements. P blocks are electronegative elements. I repeat, what are D blocks? D block elements are located in between S block and P block. We have to modify this concept or modify the definition. D blocks are located in between the characters of electropositive and electronegative. And the D block to electropositive and electronegative nadive ide. So this is the main heart of the periodic table. It consists of the 4 series: 3D, 4D, 5D and 6D. There are 4 series. This comes under in your D block. Yes. Now the D block is another name is called transition elements. Yes, this is a wonderful question. That's why they are under transition. Simple. You keep in your mind this whole topic is depend on the one word. ಅಂದ್ರೆ ಇಡೀ ಪಾಠ ಒಂದೇ ಶಬ್ದದ ಮೇಲೆ ನಿಂತಿದೆ ಮಕ್ಕಳೇ, because they are having unpaired electrons. You keep in your mind. ಈ ಪಾಠ ಪೂರ ನಿಂತಿರೋದು ಒಂದೇ ಶಬ್ದದ ಮೇಲೆ because of unpaired electron. 99% question ಗೆ ಉತ್ತರ ಏನಪ್ಪಾ ಅಂದ್ರೆ unpaired electron. Yes, why d block elements are transition elements? Yes, first simply we have to answer d blocks are located between, yes, electropositive and electronegative. And d blocks are also called transition elements because they contain maximum number of unpaired electron. Yes, when and where, yes, it is available in either atomic form or either corresponding their ionic. Yes, this is a simple concept. I define once again. Transition elements. D block elements are called transition elements because their atoms or ions at ground, as their atoms or ions at the ground state having unpaired electrons, or another word you can pronounce, yes, in the place of unpaired electron you can use another term, yes, having, yes, incomplete d orbital. ಏನಂತೀರ ಮಕ್ಕಳೇ? Yes, d block transition element ಅಂತ ಯಾಕೆ ಕರಿತೀವಿ ಅಂದ್ರೆ, yes, their atoms are their ions at the ground state they having unpaired electron, ಅಥವಾ they are incomplete d orbitals. They are also known as the d block elements. I repeat, the d blocks, the concept completely depend upon unpaired electrons, and these unpaired electrons helps to explain their characteristic transition state. Yes, the d blocks are known as transition elements. You keep in your mind, and this is a basic concept. Yes, in the next video we continue the part of d block, their elements and electronic configuration. Thank you. Yes, welcome to everyone. Today we want to be next bit of the topic is d block elements. Yes, already we know friends, d blocks are located in between s and p block. Why they are called transition metals? Because their atoms or their ions at the ground state having incompletely filled or partially filled. The d block, which consists of 4 series, already we know it's 3D, 4D and 5D and 6D series. Let us begin with 3D series. As every d block element consists of, and a series consists of 10 elements. Yes, here it is started with scandium, is end with zinc. Yes, 4D series which consists of also 10 elements. Yes, this is yttrium to the cadmium, and 5D series is also consists of the 10 elements. We have an lanthanum to the mercury. Yes, these are the 3 series, major concept of our syllabus. Yes, in our use second year we concentrate on only the first series. Basically keep in your mind first series of transition or either 3D series of d block. And this is in the first series or either 3D series. The first series, second series and third series of your d block, ಅಥವಾ 3D series, 4D series and 5D series ಅಂತ pronounce ಮಾಡಬಹುದು. Yes, here it consists of these 10 elements. And in these 10 elements, except these 3, keep in your mind, except these 3, under zinc, cadmium, mercury, except these 3, all elements or all remaining elements are called transition elements. Yes, these 3 are not any transition element. Where ಇಲ್ಲಿರುವಂತ ಎಲಿಮೆಂಟ್ಗಳಲ್ಲಿ ಈ 3 ಎಲಿಮೆಂಟ್ಗಳನ್ನ ನಾವು ಟ್ರಾನ್ಸಿಷನ್ ಎಲಿಮೆಂಟ್ ಅನ್ನೋದಿಲ್ಲ, ಉಳಿದಿದ್ದೆಲ್ಲ ಟ್ರಾನ್ಸಿಷನ್ ಎಲಿಮೆಂಟ್ ಅಂತ ಕರೀತೀವಿ ಮಕ್ಕಳೇ. ಈ 3 ಎಲಿಮೆಂಟ್ ಯಾಕೆ ಟ್ರಾನ್ಸಿಷನ್ ಎಲಿಮೆಂಟ್ ಅನ್ನೋದಿಲ್ಲ ಅಂದ್ರೆ, ಬಿಕಾಸ್ ದೇ ಆರ್ ಕಂಪ್ಲೀಟ್ಲಿ ಫಿಲ್ಡ್ ಡಿ ಆರ್ಬಿಟಲ್. ಡಿ ಆರ್ಬಿಟಲ್ಗಳಲ್ಲಿ ಕಂಪ್ಲೀಟ್ಲಿ ಫಿಲ್ ಆಗಿರುತ್ತೆ. ಟ್ರಾನ್ಸಿಷನ್ ಆಗ್ಬೇಕಾದ್ರೆ ಏನಿತ್ತು, ಡಿ ಬ್ಲಾಕ್ ಇಸ್ ಪಾರ್ಷಿಯಲಿ ಫಿಲ್ಡ್ ಅಥವಾ ಇನ್ಕಂಪ್ಲೀಟ್ಲಿ ಫಿಲ್ಡ್. ಬಟ್ ಈ 3 ಎಲಿಮೆಂಟ್ ಕಂಪ್ಲೀಟ್ಲಿ ಫಿಲ್ ಆಗಿರೋದ್ರಿಂದ ಯಾವುದೇ ಕಾರಣಕ್ಕೂ ಜಿಂಕ್, cadmium and mercury, they are not called as a transition. Except these 3, the remaining elements are commonly we pronounce as a transition element. Yes, let us start one by one, friends. In the 3D series, as I mentioned in our syllabus, the totally 10 elements. What are those? Yes, we start with the first one. Scandium, yes, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. These are the element. Atomic number, yes, this is your atomic number. Scandium is 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Yes, the atomic number starts from 21 to 30 is the first series, or either the 3D series of the D block elements. Consists of 10 elements: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. We concentrate these 10 elements is very, very important for this year. Yes, only because of these 10 elements, friends, you can earn minimum 4 marks from this year. The topic D block as well as coordination compounds with corresponding atomic number. Atomic number ಬರಬೇಕು ಮಕ್ಕಳೇ, ಅದಕ್ಕೆ ಸಂಬಂಧಪಟ್ಟಂತ ಎಲಿಮೆಂಟ್ ನಮಗೆ ಗೊತ್ತಿರಬೇಕು. So this is a brief introduction part of your 3D series elements in our part. This the next very important concept of our syllabus is the electronic configuration. I think all of you know the electronic configuration of the SPDF. Yes, today we have a general electronic configuration of D block. Yes, we have to pronounce this n-1d 1 to 10 ns 1 to 2 friends. Yes, the general electronic configuration n-1 1 to 10 ns 1 to 2, or completely we have to mention like this here also. Yes, this is noble gas with this n-1 also in our convenience. Yes, this is n-1 because it's a penultimate shell, friends. When so the electron is first occupies to the s orbital and then enter into the d orbital. There are two, penultimate and anti-penultimate. Due to the penultimation, the electron is occupies first to the s orbital. This is general. I repeat, this is also 1 mark question. You mention general electronic configuration of D block, noble gas n-1 d 1 to 10 ns 1 to 2. This is the electronic configuration of your D block. Yes, as our convenience, we have an tabulation with your component atomic number, yes, elements, a symbol, their corresponding electronic configuration. So friends, it's a very simple concept. Yes, atomic number is 21. Scandium symbol is Sc. Yes, at 21 total. Yes, electrons are 21. Yes, you can use an argon. Argon is a noble gas with stable electronic configuration of 18 electrons. Yes, everybody, argon. Yes, 18. Yes, 1s2, 2s2, 2p6, 3s2, 3p. Yes, this is a 10. This is a 6. This 18 electron is complete. And then enter into the, yes, this is 18 electron, and this is next to the 3d and 4s. Already we know it's due to the penultimate, the electron is first entering into the s orbital. Yes, once it enters into the s orbital, 18 plus 2 is 20, and remaining is 1. And this is an electronic configuration of scandium, argon 3d1 and 4s. Yes, number 22. Scandium. Yes, this is a titanium. Titanium. The symbol is a Ti. Similarly, argon. 3d and 4s. The two electrons. 18 plus 2 is 20. 22. Titanium. Yes, 23. Vanadium. Vanadium. Yes, the symbol is the electronic configuration. Argon 3d and 4s. Same 18, 20. Yes, this is your 23. And this next one is the 24 chromium. The symbol is the Cr and has a very interesting electronic configuration. And little concentrate here, friends. This is a 3D and 4S. 18. Commonly we write it is 18. Yes, these are 2, sir. Yes, 18, 20. Yes, you can write it as a 4. But it is a wrong electronic configuration. Why, sir? Why it is wrong? Because, friends, keep in your mind, d orbital is having 5 solutions. Yes, this is a 1, 2, 3, 4. It is partially incomplete. This is your D, 3D, and this is a 4S. Due to this partially incomplete, they can accept an electron from S orbital. So, you one electron it becomes partially incomplete, partially complete. Yes, this is the partially complete, the loss of one electron from S orbital. So, the electronic configuration here I can apply 3d5 and 4s1 only. Stabilization ಗೆ ಮಾತ್ರ ಅಂದ್ರೆ 3d4 ಬರಿಬಾರದು, 4 ಬದಲಿ 3d5 ಆಗ್ತದೆ, 3d9 ಬರಿಬಾರದು, ಆವಾಗ 3d10 ಆಗ್ತದೆ. In the special case chromium and copper. ಅದರ electronic configuration ಸರಿ ಮಾಡೋಣ ನಾವೀಗ. Yes, this is a 4s1, this is a 3d5. ಹೇಳಿದನ ಯಾಕೆ ಬರಿಬಾರದು ಅಂದ್ರೆ 4 ಎಲೆಕ್ಟ್ರಾನ್ ಬಂದ್ರೆ d orbital is partially incomplete. ಹಾಗಾಗಿ they accept one electron from s orbital to become s partially complete. Now the electronic configuration is a 3d5 and 4s1. Yes, next one is a 25. It's a manganese. Scandium, titanium, indium, chromium, manganese. Yes, symbol is Mn. Yes, you can pronounce. Yes, this argon as a 3d and 4s. 18, 20, 25. Okay, now friend 26. Scandium, titanium, iridium, chromium, manganese, and next to the iron. Yes, this is iron. Symbol is Fe. Iron is in two concepts. One is a ferrous and ferric. Yes, we will discuss later. This is argon, 3d and 4s. 2 here. 26. Sir, here it is a 6. And next one is 27. S, manganese iron. This is a cobalt. Symbol is a CO, you write it like this, C capital, O is small. Yes, argon, 3d7 and 4s. Yes, as our convenience, we write it here, friends. And another 3, 28 is a nickel. Symbol is Ni. Electronic configuration is like this, argon, 3d and 4s. 20, 28. Now the problem will start here. 29, copper. Symbol is Cu. Yes, argon, 3d and 4s. If you write like this, 2 and this is your S9. This is also wrong because 9 is partially. Once again, we know already this is your electronic configuration of 3d. And this is a 4s. 1, 2, 3, 4, 5, 6, 7, 8, 9 electron. And this is a 4. Yes. Due to completely half filled, so they can accept 1 electron, friends. Due to 1 electron, they becomes to the 3d10 and 4s1. This is your special case copper. Yes, you concentrate the 2 elements as mentioned. One is chromium and another one is copper. 3d10 and 4s1. The last element is zinc. Yes, atomic number is 30. Yes, the electronic configuration argon 3d10 and 4s2. Okay, friends, keep in your mind that zinc is not a transition because it is completely filled orbital at the ground state. But copper is also 3d10. But this 1 electron is accepted from the s orbital due to the penultimation. This is simple electronic concept or electronic configuration of the 10 elements from scandium to the zinc. I repeat, scandium, titanium, iridium, chromium. In this case, we have to concentrate on 2. One is chromium, argon 3d5 and 4s1, and the copper is 3d10 and 4s1. This is the first general properties of the your D block. I repeat once again, what about the general electronic configuration? Do it fast. Noble gas, n-1, D 1 to 10, ns 1 to 2 friends. This is the general electronic configuration of D block. 1 mark question. In some cases, in PUC first year, they ask chromium and copper. Maybe have any chance in the electronic configuration of these two special cases. Okay. In the next video, we continue the next general properties, atomic size of your syllabus. Thank you. Thank you so much. Welcome to everyone. Today we move on to the physical properties or general properties of D block elements. Among that, we have several concepts: atomic size, ionic radii, ionization potential, metallic character, and under one the corresponding their melting point and boiling points. Today we have a very simple concept of periodic table. In the periodic table in PUC first year, friends, keep in your mind this is a very interesting concept. This is atomic size. Always atomic size is decreases along the period. I repeat, atomic size always decreases along the period because the next electrons enter into the same orbital. The next electrons enter into the same orbital. Yes, this is decreases along the period, which mentioned is D. Yes, in down the group, it must be increases. Atomic size is increases because the principal valence shell increases. Group yes, increases down the group because the principal valence shell increases. Atomic size increase along the period decrease. This is the general concept of periodic table. Atomic size along the period decrease look like this. Next electron is enters. Yes, down the group atomic size increases because the principal valence shell itself is increases. This is simple. Yes, today we have an interesting part of our syllabus. What happens atomic size in 3D series? We have an element scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. This is keep in your mind along the period. Along the period. Okay. Yes, along the period. Basically, along the period, atomic size decreases. Atomic size decreases by increasing in atomic number. By increasing in atomic number. Atomic number atomic size decrease ಆಗಬೇಕು. This is general concept. But in 3D series, what happens? Is it agree with the same one line agenda? Decrease ಆಗ್ತಾ ಹೋಗ್ತದೇನಾ ಅಥವಾ ಚೇಂಜ್ ಇದೆನಾ? So ಅದನ್ನ ಕಲಿಯೋದು very important ಮಕ್ಕಳೇ. Atomic size ಅದಕ್ಕೆ ಹೇಳಿದ್ದು atomic size in 3D block. It is question number 24A. Sometimes it is also 3 marks question. Either sometimes 2 marks or either 3 marks. Why said it is a 3 marks? Because we have a 3 answer to this line. ಇದಕ್ಕೆ 3 ಉತ್ತರ ನಾವು ಹೇಳಕ್ಕೆ ಬರಬೇಕು ಮಕ್ಕಳೇ. ಏನು ಸರ್? The first very interesting aspect, yes, as we know, as along the period is first point decreases. Yes, along the period it is decreases. And then second very important, yes, that becomes a constant at the center. That is a constant ಆಗ್ತದೆ. And the third point, yes, it is increases. ಏನಪ್ಪ ಇದು 3 ತರನೂ ಆಗುತ್ತಾ? Decrease, constant, increase. Yes, let us begin with one by one. Sir, why it is decreases? Our answer is ready. Yes, why it is decreases? Because next electron enter into the same orbital. Yes, next electron is entering into the same orbital. Yes, the atomic size decreases. Once atomic size decreases, after vanadium, yes, chromium onwards, that becomes to the constant friends. So why it is a constant? This is due to the shading effect, or we call it as a screening effect also. It's a shielding effect ಅಥವಾ screening effect. We know what is a shielding effect. Shielding effect ಅಂದ್ರೆ ಏನು ಹಾಗಾದ್ರೆ? Yes, the inner orbitals are having maximum number of electrons. Outer orbitals are having minimum number of electrons. ನೋಡಿ, ಒಳಗಿನ ಆರ್ಬಿಟಲ್ ಅಲ್ಲಿ ಹೆಚ್ಚು ಎಲೆಕ್ಟ್ರಾನ್ಗಳಿದ್ದು ಹೊರಗಿನ ಆರ್ಬಿಟಲ್ ಅಲ್ಲಿ ಕಡಿಮೆ ಎಲೆಕ್ಟ್ರಾನ್ಗಳಿದ್ದರೆ yes, these electrons are easily shielded the nucleus. So the outer electron can easily escape out. This concept is called shielding. ಅಂದ್ರೆ ಏನಂತಾನೆ, inner orbital having maximum number of electron, outer orbital having minimum number of electron. ಅಂದ್ರೆ ಒಳಗಡೆ ಹೆಚ್ಚು ಎಲೆಕ್ಟ್ರಾನ್ಗಳಿದ್ದು ಹೊರಗಡೆ ಕಡಿಮೆ ಎಲೆಕ್ಟ್ರಾನ್ಗಳಿದ್ದರೆ ಒಳಗಡೆ ಇದ್ದ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ನ್ಯೂಕ್ಲಿಯಸ್ ಅನ್ನು ಹಿಡಿದು ಬಿಡುತ್ತದೆ. ಸೊ ದಟ್ ಈಸ್ ಅವಾರ್ಡ್ ಎಫೆಕ್ಟಿವ್ ನ್ಯೂಕ್ಲಿಯರ್ ಚಾರ್ಜ್. ಅವಾಗ ಔಟರ್ ಎಲೆಕ್ಟ್ರಾನ್ಗಳನ್ನು ನಾವು ಈಸಿಯಾಗಿ ತೆಗೆಯಬಹುದು. ದಿಸ್ ಇಸ್ ಶೀಲ್ಡಿಂಗ್ ಇಫೆಕ್ಟ್. ಬಟ್ ಡ್ಯೂ ಟು ಶೀಲ್ಡಿಂಗ್ ಇಫೆಕ್ಟ್, ವೈ ಇಟ್ ಇಸ್ ಶೀಲ್ಡಿಂಗ್ ಇಫೆಕ್ಟ್? ದ ಇನ್ನರ್ ಆರ್ಬಿಟಲ್ಸ್ ಆರ್ ಹ್ಯಾವಿಂಗ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಎಲೆಕ್ಟ್ರಾನ್. ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಡಿ ಆರ್ಬಿಟಲ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ಗಳ ಸಂಖ್ಯೆ ಹೆಚ್ಚಾಗುತ್ತಾ ಹೋಗುತ್ತದೆ ಮಕ್ಕಳೇ ಔಟರ್ ಆರ್ಬಿಟಲ್ಗಳಿಗಿಂತ. ಅದಕ್ಕೆ ನೆನಪಿಡುವರಿ, ಎಸ್ ಆಫ್ಟರ್ ವೆನಿಡಿಯಂ, ಎಸ್ gradually the concept is constant. Finally, after copper, then once again it becomes to be increases. Sir, why it is increases? Because completely filled d orbital. d orbital complete ತುಂಬಿದ ಮೇಲೆ they becomes more stable. Due to more stability, the size is gradually increases. ನೋಡಿ, ನಾನು ಇನ್ನೊಂದ್ಸಲ ಹೇಳ್ತೇನೆ ಮಕ್ಕಳೇ, ಉತ್ತರ ಬಹಳ ಸಿಂಪಲ್ ಅದ. ಅಟೋಮಿಕ್ ಸೈಜ್ ಇನ್ 3D series is not firm for one line agenda. ಡಿಕ್ರೀಸ್ ಅಂಬೇಡಿ, ಇದು ಮೂರು ಕಾನ್ಸೆಪ್ಟ್ಗಳನ್ನು ಕೊಡುತ್ತದೆ. ಸರ್, ಇಟ್ ಇಸ್ ಅ ಡಿಕ್ರೀಸಸ್. ಸ್ಟಾರ್ಟಿಂಗ್ ಅಲ್ಲಿ ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ ಬಿಕಾಸ್ ದ ನೆಕ್ಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇಸ್ ಎಂಟರ್ ಇನ್ ಟು ದ ಸೇಮ್ ಆರ್ಬಿಟಲ್. ಅದೇ ಆರ್ಬಿಟಲ್ಗಳಿಗೆ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ಬರುವುದರಿಂದ ಸೈಜ್ ಶ್ರಿಂಕ್ ಆಗ್ತದೆ. ಸರ್, ಅಟ್ ದ ಸೆಂಟರ್ ಕ್ರೋಮಿಯಂ ಅಥವಾ ವೆನಿಡಿಯಂ ಆನ್ವರ್ಡ್ಸ್ it becomes constant. ಕಾರಣ ಶೀಲ್ಡಿಂಗ್ ಇಫೆಕ್ಟ್ ಅಥವಾ ಇನ್ನೊಂದು ಹೆಸರು ಸ್ಕ್ರೀನಿಂಗ್ ಇಫೆಕ್ಟ್. ಎಸ್, ಅದನ್ನು ನಿಮಗೆ ಹೇಳಿದ್ದೇನೆ ನಾನು. and then finally this once again is increases after copper is increases because the d orbital is completely filled. ಅಂದರೆ ನೀವು ಮೂರು ಆನ್ಸರ್ಗಳನ್ನು ನೆನಪಿಡ್ತೀರಾ. in a 3D series the atomic size is variation. ಕ್ವಶನ್ ಕೇಳ್ತಾನೆ, why atomic size is variable? ಯಾಕೆ ವೇರಿಯೇಷನ್ ಆಗ್ತದೆ ಅಂದ್ರೆ ಬರೀತೀರಾ. ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ ಸರ್, ಕಾನ್ಸ್ಟೆಂಟ್ ಉಳಿತದೆ, ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೆ. ಡಿಕ್ರೀಸ್ ಆಗಲಿಕ್ಕೆ ಕಾರಣ ದ ನೆಕ್ಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ಅದೇ ಆರ್ಬಿಟಲ್ಗೆ ಬರ್ತದೆ. ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಲಿಕ್ಕೆ ಕಾರಣ ಶೀಲ್ಡಿಂಗ್ ಇಫೆಕ್ಟ್ ಆಗ್ತದೆ. ಇನ್ಕ್ರೀಸ್ ಆಗಲಿಕ್ಕೆ ಕಾರಣ ಕಂಪ್ಲೀಟ್ಲಿ ಫಿಲ್ಡ್ ಆಫ್ ಡಿ ಆರ್ಬಿಟಲ್. ದಿಸ್ ಇಸ್ ಸಿಂಪಲ್. 3 ಪಾಯಿಂಟ್ 3 ಮಾರ್ಕ್ಸ್, 3 ಲೈನ್ ಅದರ ಕನ್ಕ್ಲೂಷನ್. ದಿಸ್ ಇಸ್ ಸಿಂಪಲ್ ಸ್ಟೋರಿ ಆಫ್ ಅಟೋಮಿಕ್ ಸೈಜ್ ಇನ್ ಯುವರ್ ಡಿ ಬ್ಲಾಕ್. ಯು ಕಾನ್ಸಂಟ್ರೇಟ್. ದಿಸ್ ಇಸ್ ಅ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ ಫಾರ್ 3 marks. Okay, thank you. We'll continue the next concept of metallic character and melting points in the next video. Thank you. Yes, hello everyone. In today's part, we have a same topic is the D and F block. In the D block, the second general properties, ionization potential, shortcut we call as IP. In some other concept is ionization energy and ionization enthalpy. You can pronounce anything. Ionization potential, ionization energy, or either ionization enthalpy. What is the meaning of ionization potential? First we know. Ionization potential ಅಂದ್ರೆ ಏನು ಸರ್? Is the amount of energy, we know in PUC first year, the amount of energy required to remove the outermost electron from a neutral gaseous atom. ಅದರ ಅರ್ಥ, ಒಂದು ಅಟಮ್ ನ್ಯೂಟ್ರಲ್ ಗ್ಯಾಸಿಯಸ್ ಅಟಮಿನ ಔಟರ್ ಮೋಸ್ಟ್ ಆರ್ಬಿಟಲ್ ನಲ್ಲಿ ಇರುವಂತಹ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ತೆಗೆಯಲಿಕ್ಕೆ ಬೇಕಾದಂತ ಎನರ್ಜಿಗೆ ನಾವು ಅಯನೈಸೇಷನ್ ಪೊಟೆನ್ಷಿಯಲ್ ಅನ್ನುತ್ತೇವೆ. ರಿಪೀಟ್, ದ ಅಮೌಂಟ್ ಆಫ್ ಎನರ್ಜಿ ರಿಕ್ವೈರ್ಡ್ ಟು ರಿಮೂವ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್ ಫ್ರಾಮ್ a neutral gaseous atom are known as ionization potential. So ಏನು ಸರ್ ಹೇಳೋದು ಗೊತ್ತಾಗ್ತಾ ಇಲ್ಲ. Yes, consider it as a gaseous atom. It requires some amount of energy to remove the outermost electron. So now it becomes an ionic form, friends. The loss of electron. Yes, ಹಾಗೆ ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಲ್ಲ, ಯಾವುದೇ ಒಂದು ನ್ಯೂಟ್ರಲ್ ಗ್ಯಾಸಿಯಸ್ ಅಟಮಿನಿಂದ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನು ತೆಗೆಯಲಿಕ್ಕೆ ಬೇಕಾದಂತ ಎನರ್ಜಿಗೆ ನಾವೇನಂತ ಕರಿತೇವೆ? ಅಯನೈಸೇಷನ್ ಎನರ್ಜಿ. So in periodic table we know basic concept in PUC first year. Once again I get back. This is ionization potential. Ionization potential always increases along the period and decreases down the group. Sir, why it is increases along the period? Because atomic size decreases. Atomic size decrease ಆದಂಗೆ electron ಅನ್ನು ತೆಗೆಯೋದು ಬಹಳ ಕಷ್ಟ ಸರ್, because effective nuclear charge is maximum. ನ್ಯೂಕ್ಲಿಯಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಗಳನ್ನು ಬಿಗಿಯಾಗಿ ಹಿಡಿಯುತ್ತದೆ, ಅವಾಗ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನು ತಕ್ಕೊಳ್ಳೋದು ಬಹಳ ಕಷ್ಟ ಆಗ್ತದೆ. ಅದರ ಸೈಜ್ ಸಣ್ಣದಾದರೆ ಅಯೋನೈಸೇಷನ್ ಪೊಟೆನ್ಷಿಯಲ್ ಹೆಚ್ಚಾಗ್ತಾ ಹೋಗ್ತದೆ. ಡೌನ್ ದ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಅಟಾಮಿಕ್ ಸೈಜ್ ಇನ್ಕ್ರೀಸಸ್. ಅಟಾಮಿಕ್ ಸೈಜ್ ಇನ್ಕ್ರೀಸ್ ಆದರೆ ದ ಎಫೆಕ್ಟಿವ್ ನ್ಯೂಕ್ಲಿಯರ್ ಚಾರ್ಜ್ ಈಸ್ ಮಿನಿಮಮ್. ಎಲೆಕ್ಟ್ರಾನ್ ಮತ್ತು ನ್ಯೂಕ್ಲಿಯಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇರುವಂತ ದೂರ ಜಾಸ್ತಿ ಆಗ್ತದೆ, ಕ್ಯಾನ್ ಈಸಿ ಟು ರಿಮೂವ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್. ಅದರ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ತಿಳ್ಕೊಳ್ಳಿ. ಸೈಜ್ ಸಣ್ಣದಾದರೆ ಅಯೋನೈಸೇಷನ್ ಎನರ್ಜಿ ಹೆಚ್ಚಾಗ್ತದೆ, ಸೈಜ್ ದೊಡ್ಡದಾದರೆ ಅಯೋನೈಸೇಷನ್ ಎನರ್ಜಿ ಕಡಿಮೆ ಆಗ್ತದೆ. ದಿಸ್ ಈಸ್ ದ ಬೇಸಿಕ್ ಕಾನ್ಸೆಪ್ಟ್ ಆಫ್ ಅಯೋನೈಸೇಷನ್ ಪೊಟೆನ್ಷಿಯಲ್. ಓಕೆ, ಎಸ್, ಬೇಸ್ಡ್ ಆನ್ ದಿಸ್ ಕಾನ್ಸೆಪ್ಟ್ ಇದು ನಿಮ್ಗೆ ಅರ್ಥ ಆಯ್ತು ಅಂದರೆ ನಾನೀಗ ಹೋಗ್ತೇನೆ ವಾಪಸ್ ನಿಮ್ಮ 3D ಸೀರೀಸ್. ನಿಮ್ಮ 3D ಸೀರೀಸ್ ಎಲ್ಲರಿಗೂ ನೆನಪಿರಲಿ. ಎಸ್, ಸ್ಕ್ಯಾಂಡಿಯಂ, ಟಿಟಾನಿಯಂ, ವೆನಿಡಿಯಂ, ಕ್ರೋಮಿಯಂ, ಮ್ಯಾಂಗನೀಸ್, ಐರನ್, ಕೋಬಾಲ್ಟ್, ನಿಕ್ಕಲ್, ಕಾಪರ್. These are the 3D series of the first series of your D block, consists of 10 elements. What happens in this? Sir, here also it is along the period. And due to the along the period, basic concept is ionization potential decreases. Sir, why it is decreases? Why it is decreases? Because, yes, sorry, ionization potential increases. Ionization potential increases because atomic size decreases. Concept of general. Atomic size decrease ಆಗ್ತಾ ಹೋಗ್ತದೆ, ionization potential increase. Increase ನೆನಪಿಟ್ಕೋರಿ, decrease ಅಲ್ಲ, increase is simple concept. This is what happens here. ಮಕ್ಕಳೇ, ನಾನು ಹೇಳಿದ್ದೇನೆ ಅಟಾಮಿಕ್ ಸೈಜ್ ಈಸ್ ಹಿಯರ್ ಡಿಕ್ರೀಸಸ್. At this stage it becomes to be constant, and after copper onwards it is increases. This is increase, this is constant. Due to shielding, this is your decreases concept. Similarly, ionization potential also is gradually increases. Sir, why it is increases? Increase ಆಗ್ತಾ ಹೋಗ್ತದೆ. ಯಾಕೆ increase ಆಗ್ತದೆ? Yes, reason as size decrease and somewhere they becomes to be constant. Elinda chromium to copper they becomes to be constant, and finally once again atomic size increases, ionization potential is also increases. Here the component is completely filled. The general ionization potential in a 3D block elements is increases because atomic size decreases, and in this case the shielding effect also and a major cause to the component. At this stage is a gradual increases. It's not perfectly constant. ನಮಗೆ ionization potential constant ಉಳಿಯೋದಿಲ್ಲ ಮಕ್ಕಳೇ, ಸ್ವಲ್ಪ increase ಆಗ್ತಾ ಹೋಗ್ತದೆ, because just one electron is entering to the your d orbital, that is a penultimate shell. Gradually it increases the component. At the end, after your copper, your ionization potential increases. You concentrate this word only, ionization potential increases. This is a simple concept. So one line is what happens in ionization potential in 3D series is gradually increases by the decreasing in atomic size. And now we come to the next one, is a metallic character. Yes, a very interesting character of this physical nature of D block elements, friends. All D block elements are basically metal or metallic character because the crystal shapes are available either CCP or either HCP or either here having BCC. Cubic close packing, hexagonal close packing, and polycentered cubic. It's due to this cubic structures, the transition metals all and above, the components are metal, except your compound is zinc or either cadmium or either mercury. They are due to the completely filled of d orbital. Their properties a little changes. They are having soft solids or either liquids. So general concept, the transition metals are metallic in nature due to the perfect crystal structures of CCP, HCP and BCC. Yes, due to the metallic characters. So friends, you start with scandium to the copper, except zinc. I have left this zinc, and these metals are very good metallic character. They can create the metal lusters. They can easy to form their oxide layers. There is a metal lusters, and they are easily ductile and easily malleable. You tanti taranu ಮಾಡಬಹುದು, ಅದನ್ನ ತಗಡು taranu ಮಾಡಬಹುದು. Yes, the metals, this is due to this reason, metallic reason, they are very good ductility and malleability, and they can easily to create the metallic lusters. And friends, keep in your mind, these metals, scandium to the copper, these metals are very good thermal conductor as well as your electrical conductor. This is why they are thermal and electrical. We will discuss later. This all reason because of unpaired electron. Due to this unpaired electron, the electron mobility will be takes place. That is called electron C model. Due to the electron mobility will be takes place, they can act as a very good metal. I repeat, transition metals except zinc, cadmium and mercury, they are very good metals because they are having a very good shapes, and they are easy to having properties of luster formations, malleability, ductility, and they are very good thermal and electrical conductor. This is the basic concept of the metallic character of transition metals. Okay, yes friends, and in the next video we continue. The next part is a melting point and a boiling point. Thank you. So welcome to everyone. So today we have a very important part of general properties in D block, melting point and boiling point. Before to start the D block, friends, you keep in your mind, in chemistry, melting point and boiling point is one basic physical constant or physical property of all matter. Yes, melting point of the D block. Yes, as compared with the S and P block, yes, the D block elements are having little higher, keep in your mind, little higher melting point or boiling point, because the reason is having intermolecular bonding or interatomic metallic bonding. So the D blocks are having higher melting points. Yes, as compared with S and P. Yes, friends, in D block, except the metals zinc, cadmium and mercury, all elements in all three series, 3D, 4D and 5D series, all are having higher melting point. Why they are having higher melting point? Because the reason interatomic metallic bond. It's very important. Interatomic metallic. Yes, what is this interatomic? Due to this is N-1 d orbital. There is a penultimate having a maximum number of unpaired electrons. Those unpaired electrons are having the formation of a bond, that is metallic bond. This is called interatomic metallic bond. Andre na innondu sala heltene makkale, interatomic andre N-1 d orbital ns ginta ಒಳಗೆ ಇರುತ್ತದೆ. This is a penultimate, and this penultimate having maximum number of unpaired electrons. ಅಂದ್ರೆ ಈ unpaired electronಗಳ ಸಂಖ್ಯೆ ಜಾಸ್ತಿ ಇರುತ್ತದೆ. ಈ unpaired electronಗಳು ತಮ್ಮ ನಡುವೆ, that is called interatomic. The interatomic metallic bondಗಳನ್ನು ಕ್ರಿಯೇಟ್ ಮಾಡ್ತದೆ. ಹಾಗಾಗಿ ಅಲ್ಲಿ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಹೆಚ್ಚಾಗ್ತದೆ. That is called, the word is unity is a strength. ನಾವು ಎಷ್ಟು ಒಗ್ಗಟ್ಟಾಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗ್ತದೆ ಅಷ್ಟು ಸ್ಟೆಬಲೈಸ್ ಆಗ್ತದೆ. ಹಾಗೆ ಮಕ್ಕಳೇ, ಇಂಟರಾಟಮಿಕ್ ಒಳಗಿರುವ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ಬಾಂಡ್ಗಳನ್ನು ತಯಾರು ಮಾಡೋದ್ರಿಂದ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಹೆಚ್ಚಾಗ್ತಾ ಹೋಗ್ತದೆ. ಐ ರಿಪೀಟ್ ಒನ್ಸ್ ಅಗೇನ್, as compared with S and P, D blocks are having higher melting and boiling point because interatomic metallic bond due to the n minus 1 d or penultimate shell having maximum number of unpaired electron, the interatomic metallic bond will be created except the metals like zinc and cadmium and mercury. And due to this reason, they become a strong metallic bond. And due to the strong metallic bond, the melting point or boiling point is always increases. Always increases. I repeat, due to strong metallic bond, the melting point, boiling point increases. So why it is increases? The reason is n minus 1 d orbitals are having maximum number of unpaired electrons. Come to the conclusion. ಎಲ್ಲರೂ ಸೇರಿ conclusion ಗೆ ಬರುವ ನಾವೀಗ ಏನಪ್ಪ ಹಾಗಾದ್ರೆ maximum number of unpaired electrons in d orbital. Maximum number of unpaired electrons in a d orbital creates interatomic metallic bond. Maximum number unpaired electron d orbital irodrinda they can create interatomic metallic bond. So the melting point or either boiling point increases. This is very important. Last one line agenda. ಯಾಕೆ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಹೆಚ್ಚಾಗ್ತದೆ ಅಂದ್ರೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ನಂಬರ್ ಆಫ್ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಡಿ ಆರ್ಬಿಟಲ್ ಗಳಲ್ಲಿ ಇರ್ತದೆ ಸರ್. ಹಾಗಾಗಿ ವಿ ಕ್ಯಾನ್ ಈಸಿ ಟು ಕ್ರಿಯೇಟ್ ಇಂಟರ್ ಅಟಮಿಕ್ ಮೆಟಾಲಿಕ್ ಬಾಂಡ್. ಡ್ಯೂ ಟು ಇಂಟರ್ ಅಟಮಿಕ್ ಮೆಟಾಲಿಕ್ ಬಾಂಡ್ ದೇ ಹ್ಯಾವ್ ಸ್ಟ್ರಾಂಗ್ ಮೆಟಾಲಿಕ್ ಬಾಂಡ್. ಬಹಳ ಸ್ಟ್ರಾಂಗ್ ಬಾಂಡ್ ಆಗ್ತದೆ. ಹಾಗಾಗಿ ಎಷ್ಟು ಸ್ಟ್ರಾಂಗ್ ಬಾಂಡ್ ಕ್ರಿಯೇಟ್ ಆಗ್ತದೆ, those component is not so easy to melt or either easy to boil. So melting point, boiling point increases. This is a simple concept of your D block. I repeat, melting point, either boiling point increases in a 3D series except these three metals. Reason is interatomic metallic bonding, that is due to the penultimate d orbital. Yes, this is a simple story of today's is melting point and boiling point. And tomorrow we have another two important concepts, oxidation state and magnetic property. Okay, thank you so much. So welcome to everyone. Today we have a very important concept of D block, variable oxidation state. Dear friends, so many times in NCERT annual examination, they ask in a 3 marks question, is question number 24, as explain the D block elements are having a variable oxidation state. So, ಯಾಕೆ D block element variable oxidation state ಅನ್ನು ಕೊಡ್ತದೆ? ನೆನಪಿಟ್ಕೊರಿ, ಆನ್ಸರ್ ಏನು ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೆ at least ಈ ಆನ್ಸರ್ ನೆನಪಿಟ್ಬಿಡಿ ಮಕ್ಕಳೇ. ನಾನು ಫಸ್ಟ್ ಹೇಳಿದ್ರೆ ಟಾಪಿಕ್ ಚಾಲೂ ಮಾಡಬೇಕಾದಾಗ ಬಿಕಾಸ್ ಆಫ್ unpaired electrons. Because of unpaired electrons, the D block elements are having variable oxidation state. Variable oxidation state. ಯಾಕೆ D block ಎಲಿಮೆಂಟ್ಗಳು ವೇರಿಯಬಲ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಕೊಡ್ತದೆ ಅಂದ್ರೆ ಒನ್ ಲೈನ್ ಆನ್ಸರ್, ಬಿಕಾಸ್ ದ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್. ಬೇಕಾದ್ರೆ ನೀವು ಇಲ್ಲಿ ಪ್ರೆಸೆನ್ಸ್ ಹಾಕಿದ್ರೆ ನಡೀತದೆ. Because the presence of unpaired electrons, they having variable oxidation state. Before to start the oxidation state, we know, yes, what is the oxidation state? How can you know the oxidation state? So like example is an atom. This is a sodium. Yes, to provide energy, that is called ionization energy, the sodium can lose the one electron, outermost orbital containing electron, and now it becomes Na plus. Yes. What about the oxidation state of sodium now here? Yes, this is plus 1. How to write the plus 1? Loss of 1 electron. ಹೇಗೆ ನೋಡಿ ಮಕ್ಕಳೇ, sodium atomic number is 11. So 11, 1s2, 2s2, 2p6, 3s1, 10 plus 1. This is outermost orbital. To to remove the outermost electron, yes, the loss of electron, it becomes to stabilize oxidation state. The loss of electron, this is 1. Yes, hagadre sodium the oxidation state is 1. ಹೀಗೆ ಪ್ರತಿಯೊಂದು ಟ್ರಾನ್ಸಿಷನ್ ಎಲಿಮೆಂಟು ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ಗಳನ್ನು ತೋರಿಸ್ತದೆ. ಕಾರಣ ಏಕೆ? ಅದರಲ್ಲಿ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ಇರ್ತದೆ. ಇದು ಮೇಜರ್ ಕಾನ್ಸೆಪ್ಟ್. ನೀವು ಹೇಳ್ರಿ ಎಸ್, ನಾ ರೀಸನ್ ಲಾಸ್ಟ್ಗೆ ನಿಮ್ಗೆ ಹೇಳ್ತೇನೆ. 3 ಮಾರ್ಕ್ಸ್ ಈ ಕ್ವಶನ್ ಕೇಳಿದೆ. ಎಸ್, ಕ್ಲಿಯರ್ why the transition elements are having variable oxidation state? Because the presence of number of unpaired electrons. Yes, we will start with one by one. Yes, the first element of our syllabus is scandium. Atomic number is 21. Electronic configuration argon. This is a 3d1 and 4s2. Yes, you can mention the orbital diagram. Yes, 1 electron in d orbital, the 2 electron in s orbital. Yes, first you have to remove the outermost orbital. This is s orbital is outermost, and these two paired electron, so automatically you can eject at a time. ಒಂದೊಂದು ತೆಗೆಯಕ್ಕೆ ಬರಲ್ಲ, ಪೇರ್ ಇದ್ದಾಗ can eject electrons to. ಎರಡು ಎಲೆಕ್ಟ್ರಾನ್ ಹೋದ್ರೆ oxidation state is +2. ಹಾಗಾದ್ರೆ ಎರಡು ಆಲ್ರೆಡಿ ಎಲೆಕ್ಟ್ರಾನ್ ಹೋಗಿದೆ, this is an s orbital, and then apply the energy to remove the inner orbital, penultimate. Now this electron is also removed, +2 is already, and along with this the oxidation state is +3. ಅರ್ಥ ಆಯ್ತಲ್ಲ? ಬೇರೆ ಹೆಂಗೆ ಔಟರ್ ಮೋಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನು ತೆಗಿಬೇಕು, ಪೇರ್ ಇದ್ರೆ ಎರಡು ಒಮ್ಮೆ ತೆಗಿತೇವೆ, +2. ನಾವು ಈಗ ಎಲೆಕ್ಟ್ರಾನ್ ಹೋದ್ರೆ oxidation state is +3. There is scandium having 2 oxidation state, +2 and +3. Similarly, scandium, titanium, 22. Yes, argon, 3d and 4s. It's 2, 2, 18, 20, 22. Yes, this is your d orbital. 1, 2. This is 2 electrons. Now, we can express. At a time, you have to eject 2 electrons. Obviously, the oxidation state is +2. Now, these are unpaired. Now, ಒಂದೊಂದೇ ತೆಗೆಯಕ್ಕೆ ಬರ್ತದೆ, unpaired ಇದ್ದಾಗ. +2 ಹೋಗಿದೆ. Now, apply here. This is +3. And then here +4. Where titanium having 3 oxidation states, +2, +3 and +4. Similarly, scandium, titanium, now come to the vanadium. This is 23. Yes, 23. Argon, 3d and 4s, 2, and this is 3. 1, 2, 3 unpaired electron. Yes, yes, you can express, please. Okay, now the oxidation state is +2, the 2 electrons. Now +3, +4, and then +5. Okay, scandium, titanium, vanadium, and now chromium. These are 24. Special case. Now here is an electronic configuration. Yes, sir. Argon, 3d, 4s. Yes, 4s1. 3d, 5. Yes, d orbital having 5 unpaired electron, 1, 2, 3, 4, 5, and now s is having 1. Just what about the oxidation state? S orbital having only 1 electron, that's why the oxidation state is +1. Now +2, +3, +4, +5, and +6. This is the simplest. This among these 4 elements, scandium having +2 and +3, titanium having +2, +3, +4, vanadium having +2, +3, +4 and +5, chromium having +1, +2, +3, +4, 5 and 6. Keep in your mind, +1. This is minimum oxidation state at this stage. Sir, okay, ಹಾಗಾದ್ರೆ ನಮಗೆ ಈ 4 ಎಲಿಮೆಂಟ್ ಆಯಿತು. And what next? Scandium, titanium, chromium. Next, ಯಾವುದು? Manganese. Atomic number is 25. Electronic configuration argon, 3d5 and 4s2. 3d5 and 4s2. Yes, you can express this is your d orbital and this is your s. 1, 2, 3, 4, 5. This is 6, 7. Now what about the oxidation state? S orbital having 2 electrons, that's why this is a +2, +3, +4, +5, +6 and +7. This is your variable oxidation state is manganese. And next, iron 26, argon 3d6 and 4s. 3d6 and 4s. Now this is your box. 1, 2, 3, 4, 5. D orbital starts with pairing here. It's 2 electrons. Sir, this is a +2, +3, +4, +5 and +6. No, 2, 3, 4, 5, 6. Yes, this is enough. Yes, D orbital is completely start pairing. It's not so easy to eject. Another D orbital, inner orbital alli pairing ಆದರೆ that is called inner to pair effect. ಹಾಗಾಗಿ ಈ ಎರಡು ಎಲೆಕ್ಟ್ರಾನ್ಗಳನ್ನ ಅಥವಾ ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇನ್ನರ್ ಆರ್ಬಿಟಲ್ ಅಲ್ಲಿ ನಾವು ರಿಜೆಕ್ಟ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ಅದರ ಐರನ್ ದ ಹೈಯೆಸ್ಟ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಎಷ್ಟು ಮಕ್ಕಳೇ? +6. ಮಿನಿಮಮ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಈಸ್ +2. ಹೇಳಿಕ್ ಬರ್ತದಾ? ಯಾಕೆ ಹೀಗೆ ಸ್ಟಾಪ್ ಆಯ್ತು ಸರ್? ಇನ್ನರ್ ಆರ್ಬಿಟಲ್ ಹ್ಯಾವಿಂಗ್ ಪೇರ್, ದಟ್ ಈಸ್ ಇನ್ನರ್ ಪೇರ್. ಮ್ಯಾಂಗನಸ್, ಐರನ್, ದಿಸ್ ಈಸ್ ಅ ಕೋಬಾಲ್ಟ್. ಕೋಬಾಲ್ಟ್ 27, argon 3d7 and 4s. 3d7 and 4s. 1, 2, 3, 4, 5, 6, 7. ಹೇಳ್ತೀರಾ? ಎಸ್, ಜಲ್ದಿ. +2, ಸರ್, +3, +4 and +5. ಫಿನಿಶ್. ಇದೆರಡು ಏನಾಗಿದೆ? Now it becomes to be paired. Due to the paired electron ultimate, they cannot be ejected. This is the oxidation state. The next of all, iron, cobalt, nickel. This is 28. Argon 3d8 and 4s2. Yes, now this is your d orbital and s 1, 2, 3, 4, 5, 6, 7, 8. These are the 2. Yes, anybody? 2 electron. S orbital outermost can easily eject. Sir, this is a +3 and this is a +3. Pair cannot be. Similarly, copper 29, argon 3d10, not an I, 3d10 for S1. And d orbital 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is your 1. But keep in your mind, Makwe, sir, this is also from S orbital. E electron is S orbital. First, I know, sir, +1 is a chance. Once you eject this electron, tagarbitri +1 ಆಯ್ತಲ್ಲ. ಎಸ್, ಇದಕ್ಕೆ ಇನ್ನೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಇಲ್ಲಿದೆಯಲ್ಲ, ಅದು ವಾಪಸ್ ಹಂಗೆ ಹೋಗ್ಬಿಡ್ತದೆ. ವಾಪಸ್ ಇದು ಬರುತ್ತೆ ಸರ್. ಅವಾಗ ದಿಸ್ ಈಸ್ ಅನ್ನ +2 is also in a chance. Copper is having +2 is also in a chance. This is the copper having +1 and +2 because the one electron is accept to the your d orbital. ಇದು ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ತಗೊಂಡಿರ್ತದಲ್ಲ, ಹಾಗಾಗಿ +1 ಇರ್ತದೆ ಸರ್. And due to this, the +1 and ejection will be experienced, the oxidation status becomes +2. Copper is +1 and copper 2. Zinc. Sir, zinc atomic number 30, argon 3d10 and 4s2. D orbital already new here completely filled sir. S orbital 2 electron ಇದೆ. ಇಲ್ಲಿ 10 ಇರುತ್ತದೆ. Same similar to the copper, but copper can accept 1 electron. ಇಸ್ಕೊಂಡಿರ್ತದೆ, ಹಾಗಾಗಿ +2. ಚಾನ್ಸ್ ಇಲ್ಲ ಸರ್. ಓನ್ಲಿ ದ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಈಸ್ +2. ನೋಡಿ ಮಕ್ಕಳು, ನಾನು ಇನ್ನೊಂದ್ಸಲ ಹೇಳ್ತಾ ಹೋಗ್ತೇನೆ. ಕೀಪ್ ಇನ್ ಯುವರ್ ಮೈಂಡ್ ದ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಆಫ್ ಟ್ರಾನ್ಸಿಷನ್ ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ ವೇರಿಯಬಲ್. ಯಾಕೆ ವೇರಿಯೇಷನ್ ಆಗ್ತದೆ ಅಂದರೆ ಎಲ್ಲದರಲ್ಲಿ ಅನ್ಪೇರ್ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ಇರ್ತದೆ. ಅನ್ಪೇರ್ ಎಲೆಕ್ಟ್ರಾನ್, ಅನ್ಪೇರ್ ಎಲೆಕ್ಟ್ರಾನ್, ಅನ್ಪೇರ್. ಅದಕ್ಕೆ ನಾನು ನಿಮಗೆ ಬಾಕ್ಸ್ ಬರೆದು ತೋರಿಸಿದ್ದೇನೆ. ಅನ್ಪೇರ್ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ಇರುವುದರಿಂದ ವೇರಿಯಬಲ್ ಆಗ್ತಾ ಹೋಗ್ತದೆ. ಸರ್, ಹಾಗಾಗಿ ಏನು ವೇರಿಯಬಲ್ ನೋಡಿ? ಎಸ್, ದ ಎಲೆಕ್ಟ್ರಾನ್ ಕ್ಯಾನ್ ಬಿ ಈಸಿಲಿ ejected. The interesting 1 mark question. ಇದ್ರಾಗ 1 marks question ಏನು? ಸ್ಕ್ಯಾಂಡಿಯಂ ಟು ದಿ ಜಿಂಕ್ ಅಲ್ಲಿ, ಎಸ್, ವೇರ್ ಯು ಹ್ಯಾವ್ ಮಿನಿಮಮ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್. ಎಲ್ಲಿ ನನಗೆ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಮಿನಿಮಮ್ ಸಿಕ್ತು ಅಂದ್ರೆ 2 ಕಡೆ ಸಿಕ್ಕಿದೆ ಮಕ್ಕಳೇ. ಒಂದು ಕ್ರೋಮಿಯಂ ಅಲ್ಲಿ +1, ಇನ್ನೊಂದು ಕಾಪರ್ ಅಲ್ಲಿ +1. ಅಲ್ಲಿ ಮಿನಿಮಮ್ ಸಣ್ಣ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ +1, ಕ್ರೋಮಿಯಂ ಅಂಡ್ ಕಾಪರ್. ನೋಡಿ ಸಾವಕಾಶ ನೋಡ್ಕೋರಿ ಮಕ್ಕಳೇ. ಇನ್ನೊಂದು ಕ್ವಶನ್ ಇದೆ. ಎಸ್, 3D series, our first series of transition elements, 3D series, which element having highest oxidation state? Yes, let's check. The highest oxidation state is manganese. The answer is +7. Highest oxidation state ಇರುವ ಎಲಿಮೆಂಟ್ ಯಾವುದಪ್ಪ ಅಂದ್ರೆ +7 ನೆನಪಿಡುವರಿ. ಎಸ್, ಅದು ಮ್ಯಾಂಗನಸ್. ಎಲ್ಲಿ? 3D series ಅಲ್ಲಿ ಮಾತ್ರ 3D series ಅಲ್ಲಿ ಮಾತ್ರ ಇದು ಹುಷಾರು. ಒಮ್ಮೊಮ್ಮೆ ಜೆ ಒಳಗೆ ಈ ಕ್ವಶನ್ ಕೇಳ್ಬಿಡ್ತಾನೆ ಮಕ್ಕಳೇ. ಎಸ್, keep in your mind which element in a D block having highest oxidation state. D block ಅಲ್ಲಿ highest oxidation state ಯಾವುದು ಅಂದ್ರೆ ಸರ್ ಒಂದು ಆಸ್ಮಿಯಂ, ಇನ್ನೊಂದು ರುಥೇನಿಯಂ. These two are +8 oxidation state. +8 oxidation state ಅನ್ನು ಕೊಡುವುದು. ಆಸ್ಮಿಯಂ and ರುಥೇನಿಯಂ is +8. 3D series ಅಲ್ಲಿ highest +7. 3D series ಅಲ್ಲಿ minimum is +1. ಅದು ಕ್ರೋಮಿಯಂ ಮತ್ತು ಕಾಪರ್. So this is very very important. This is the concept of a variable oxidation state in D block. Keep in your mind, this is very important. Yes, keep practicing to the variable oxidation state. In the next video, we discuss the continuity part of this. So why they are variable? I have one reason, yes, because of unpaired electron. We have another two reasons why they are introduced to be variable. We discuss in the next video. Thank you. Welcome to everyone. In the last video, I have to discuss the major concept of oxidation states, and in this category, in the oxidation state of 3D series, especially we discussed in the last class, from scandium to the zinc, we have variable oxidation state. The major question will ask in annual examination in question number 23 or either 24 is a 3 mark question, is why the D block elements or 3D series shows variable oxidation state. Yes, or sometimes they ask a question like this. Yes, what are the causes of variable oxidation states? These are the 3 important points you mentioned for that question. The first is variable oxidation state due to the maximum number of unpaired electrons present in D orbital. This is the first answer. This means maximum number of unpaired electrons present in D orbital. And second is very important. The valential electrons of transition elements. Valential means outermost valential electrons in n-1d and ns. At the 2 orbital and outermost D orbital and ns orbitals are having a little difference in their energy. The energy difference of these 2 orbitals are very less, friends. Very very less. Due to this less energy, or both are having equal energy, they can easy to form a bond. And we will already discuss as due to the interatomic bond formation of the D orbital due to the maximum number of unpaired electrons. So ಹೇಳ್ರಿ, the valential electronಗಳು transition element ಅಲ್ಲಿ n-1d ಮತ್ತು ns electron ದ ಎನರ್ಜಿ almost similar or difference ಬಹಳ ಕಡಿಮೆ ಇದೆ. That's why the both atomic orbitals are easy to bond formation. So this is the reason they shows variable oxidation state. The third point, they shows +2 oxidation state due to the 2 electrons which present in outermost ns orbital, means outermost orbital, and whereas the electrons of n-1d remains unaffected. ಹಾಗಾದರೆ D orbital ಅಲ್ಲಿ ಯಾವುದೇ ಎಲೆಕ್ಟ್ರಾನ್ಗಳಿಗೆ ಅದು ಇಫೆಕ್ಟ್ ಮಾಡಲ್ಲ. ಈ 3 ರೀಸನ್ಗಳನ್ನು ನೆನಪಿಡಿ. ಹಾಗಾದರೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ನಂಬರ್ ಆಫ್ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ಇರುತ್ತದೆ. D orbital means n-1d orbital, ns orbital ದ ಎನರ್ಜಿ ಸೇಮ್ ಇರೋದ್ರಿಂದ both easy to formation of bond. Next one, ns orbital ಅಲ್ಲಿ 2 ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ಇರುತ್ತದೆ. Yes, those electrons shows +2 oxidation state. They cannot be affected on D orbital. ಅದು D orbital ಮೇಲೆ ಯಾವುದೇ ಎಫೆಕ್ಟ್ ಅನ್ನು ಮಾಡಲ್ಲ ಮಕ್ಕಳೇ. ಈ 3 ಪಾಯಿಂಟ್ ಅನ್ನು ನೀವು ಮೆನ್ಷನ್ ಮಾಡಿಬಿಟ್ರೆ can get the 3 marks from that question number 24 in your annual examination. This is a major point of your syllabus. Apart from this, the reason, the causes, the reason, as we have some simplest part of this oxidation state as maybe the 1 mark question. Maybe if they split into the 1 plus 1 plus 1, ಅದೇ 1 mark question ಮಾಡಿದ್ರೆ ಅದು ಯಾವ್ದು ಬರ್ಬೋದು? ಇಲ್ಲ ಸರ್, ವಾಟ್ ಅಬೌಟ್ JEE and NEET ಕ್ವಶನ್ ಯಾವ್ದು ಬರ್ಬೋದು? ಸ್ವಲ್ಪ ನಾವು ಇಲ್ಲಿ ಡಿಸ್ಕಷನ್ ಮಾಡ್ಕೊಳ್ಳೋಣ ಮಕ್ಕಳೇ, ಬಿಕಾಸ್ oxidation state is the major part of this chapter. We have a very simple in a 3D series. Let us begin with the 3D series. The minimum, keeping on minimum oxidation state. ಅತಿ ಕಡಿಮೆ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಯಾವುದು? That is a +1. ಎಲ್ಲಿ ಬರ್ತದೆ? The case of chromium and copper ಮಕ್ಕಳೇ. maximum oxidation state +7 ಬರ್ತದೆ. In the case of manganese, if you want to take an example, is a compound is a potassium permanganate. You know in PUC first year, this potassium is alkali metal +1 oxidation state. Oxygen is -2, is multiplied by 4, that is a -8. Automatically manganese becomes to be +7. So the maximum oxidation state is +1 in 3D series. In a D block, if they ask the question in D block, general question, what about the minimum oxidation state? What about the maximum oxidation state? So minimum, obviously we know there is a +1, maximum is a +8. Maximum is a +8. One answer are in category osmium or either rhodanium. These are the two best examples. Yes, so many times in Karnataka city they ask this question: which of the following element having highest oxidation state in a D block? Answer: osmium. Several times they ask, that is a +8. Yes, in 3D +7, minimum is +1. The minimum andre idu nenepidu +1. Bala makkalu confusion maadu, hey sir, scandium is minimum, like +2 +3 ಬರ್ತದೆ, ಹಾಗಾಗಿ ಅದೇ minimum. Maximum ಯಾವುದು ಅಂದ್ರೆ ಸರ್ manganese is maximum, ಯಾಕಂದ್ರೆ +2 +3 +4 +5 +6 +7 ಇಷ್ಟು ಬರ್ತಾವೆ, ಇಷ್ಟು ನಂಬರ್ ಅದು. ಸೊ ಮಿನಿಮಮ್ ಅಂದ್ರೆ ಯಾವುದು, ಮ್ಯಾಕ್ಸಿಮಮ್ ಅಂದ್ರೆ ಯಾವುದು ನೆನಪಿಟ್ಕೋಬೇಕು ಮಕ್ಕಳು. ಇಟ್ಸ್ ಅ ವೆರಿ ಇಂಟ್ರೆಸ್ಟಿಂಗ್ ಕ್ವಶನ್, ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ತದೆ. ಸೊ ಮಿನಿಮಮ್ ಮತ್ತು ಮ್ಯಾಕ್ಸಿಮಮ್ ಕೇಳಿದ್ರೆ ಮಿನಿಮಮ್ ಅಂದ್ರೆ ಏನು ಹೇಳ್ತೀರಾ, ಕ್ರೋಮಿಯಂ ಮತ್ತು ಕಾಪರ್ ಸರ್ +1 ಇರ್ತದೆ. 3D ಸೀರೀಸ್ ಅಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಅಂದ್ರೆ +7 ಇರ್ತದೆ ಸರ್. ಎಕ್ಸಾಂಪಲ್ ಬೇಕಾದ್ರೆ ನಾನು ಹೇಳಿದ್ದೇನೆ, ದಟ್ ಇಸ್ ಪೊಟ್ಯಾಷಿಯಂ ಪರಮಾಂಗನೇಟ್ ಸರ್. ಡಿ ಬ್ಲಾಕ್ ನೆಕ್ಸ್ಟ್ ಯಾವುದು ಸರ್, ದಟ್ ಈಸ್ ಯುವರ್ +1 is chromium and copper, +8 is osmium and rhodium. ಎಸ್, ಇದನ್ನು ಬಿಟ್ಟು ಮತ್ತೆ ಇನ್ನೂ ಕ್ವಶನ್ ಕೇಳಬಹುದು. ಎಕ್ಸೆಪ್ಟ್ ಇನ್ 3D series, except manganese, which element shows maximum oxidation state? ಯಾವ ಎಲಿಮೆಂಟ್ ಹೈಯೆಸ್ಟ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಅನ್ನು ತೋರಿಸ್ತದೆ ಅಂದ್ರೆ ದಟ್ ಬಿಕಮ್ಸ್ ಟು ದಿ ಯುವರ್ ಕ್ರೋಮಿಯಂ ಆಸ್ ವೆಲ್ ಆಸ್ ಐರನ್ ಆಲ್ಸೋ ಫ್ರೆಂಡ್ಸ್. ಕ್ರೋಮಿಯಂ ತೋರಿಸುತ್ತೆ +6, ಐರನ್ ನಲ್ಲಿ +6 ಬರ್ತದೆ. ನೀವು ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಬರ್ಕೊಂಡ್ರಿ ಅಂದ್ರೆ ಯು ಕ್ಯಾನ್ ಈಸಿ ಟು earn that 1 mark. These are the 1 mark questions. Sometimes split 24A, 24B, 24C. Explain why transition elements are variable oxidation state. Yes, it gives the 2 reasons, and which element having a highest oxidation state, which elements are having the minimum oxidation state. The oxidation state calculate ಮಾಡಲಿಕ್ಕೆ ನಮಗೆ ಕಂಪಲ್ಸರಿ ಬರಬೇಕು. You keep practicing oxidation state, you have by heart, it is far better. Yes, you can get the 3 marks. Yes, it's a very major part of this chapter. Yes, in the next video we have a simple calculation, that is magnetic moment. Magnetic moment ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋಣ ನಾವು ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ. ಥ್ಯಾಂಕ್ ಯು ಸೋ ಮಚ್ ಫಾರ್ ದ ವಾಚಿಂಗ್. So welcome to everyone. Today we have next bit of the topic is magnetic properties of D block elements. So we know in a basic concept of solid state, friends, magnetic properties of various types: paramagnetic, diamagnetic, ferromagnetic, antiferromagnetic and antiferromagnetic. The magnetic properties are variation. In that category, yes, we have 2 very major part is magnetic properties. It's a 2 major part. One is paramagnetism and another one is diamagnetism. Yes, what are paramagnetic materials and diamagnetic? Paramagnetic and diamagnetic. Yes, we know the simple definition. What are paramagnets? Yes, you use a substance or you keep in a substance in a magnetic field. If the magnetic field is a repulsion will takes place. The substance you keep under the magnetic field and the component is, or this magnetic field is undergoes repulsions, and this is known as a paramagnetic. Yes, you kept a substance into the magnetic field. If that magnetic field is undergoes attracts, those substances are called diamagnets. Paramagnetic substance undergoes repulsions, the diamagnets are your attraction. Why it undergoes repulsion? This repulsion is completely depend upon number of unpaired electrons. Due to the number of unpaired electrons, the paramagnetic behavior will be shows, and diamagnetic means due to the paired electrons. ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ ಮಕ್ಕಳೇ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಸಬ್ಸ್ಟೆನ್ಸ್ ಅನ್ನ ನಾವು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಇಟ್ಟಾಗ ಅದು ಏನಾದರೂ ರಿಪಲ್ಷನ್, ಅದು ದಬ್ಬಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತು ಅಂದ್ರೆ ಅದು ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್. ಅದು ಯಾಕೆ ರಿಪಲ್ಷನ್ ಆಗ್ತದೆ ಅಂದ್ರೆ ಅಲ್ಲಿ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ಇರ್ತದೆ. ದ ಸಬ್ಸ್ಟೆನ್ಸ್ ಇಸ್ ಕೆಪ್ಟ್ ಅಂಡರ್ ದಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಸಬ್ಸ್ಟೆನ್ಸ್ ಅನ್ನು ಹಾಕಿದಾಗ ಅಟ್ರಾಕ್ಟ್ ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಯ್ತು ಅಂತಂದ್ರೆ ಸರ್ ಅದು ಡಯಾಮ್ಯಾಗ್ನೆಟಿಕ್. ಕಾರಣ ಎಸ್ ದೋಸ್ metal or the component having paired electrons. A simple question ನಿಮ್ಗೆ ಕೇಳಬಹುದು, yes why the d block elements shows paramagnetic in nature, or why the transition metals are paramagnetic. One more, because ನಾನು ಸ್ಟಾರ್ಟ್ ಹೇಳಿದ್ದೇನೆ ನಿಮಗೆ, the every answer is single because of unpaired electron. Yes, the paramagnetic due to the unpaired electron, diamagnetic due to the paired electron. Yes, this is the basic. Yes, based on this we have a calculation of magnetic moment. This magnetic moment ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಬರ್ತದೆ. So how to calculate the magnetic moment? It's a very important magnetic moment. Yes, it is represented as a symbol is mu. Yes, mu is equal to square root of n into n plus 2. This is your formula. Yes, with having an unit is a bm. Bm stands for Bohr magneton. Bohr magneton. What it indicates? N stands for number of unpaired electrons. How to calculate the magnetic moment? Formula nenepittugori. Magnetic moment is equal or nothing but is a mu is equal to square root of n into n plus 2. You keep in your formula. N into n plus 2. Yes, unit is Bm. The full form is Bohr magneton. N stands for number of unpaired electrons. This is very simple help to calculation of magnetic moment values. Yes, if you get the zero magnetic moments, mu value 0 ಬಂದ್ಬಿಡ್ತು ಅಂದ್ರೆ keep in your mind those are diamagnets. If you have a certain value, ಇಷ್ಟು ಏನಾದರೂ ವ್ಯಾಲ್ಯೂ ಬಂತು ಅಂದ್ರೆ ಆ ಕಾಂಪೌಂಡ್ ಏನಂತಂದ್ರೆ ನಾವು ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟ್. ಅದರ ವ್ಯಾಲ್ಯೂಸ್ ಬಂದ್ರೆ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟ್, 0 ಬಂದ್ರೆ diamagnet. Okay, how to calculate, sir? One question ಕೇಳಿದಾರೆ so many times they ask the question. Question number 24a. Yes, calculate mu value or magnetic moment value of copper plus 3. Question ಬರುತ್ತೆ 2 marks. Calculate the mu value of chromium plus 3. Very simple. How to know to calculate this chromium plus 3? Before to plus 3, we know the electronic configuration of chromium, friends. Atomic number 24. Yes, electronic configuration argon, 3d and 4s. Chromium is special case. Yes, this is a 3d5 and 4s1. This is your electron distribution. 1, 2, 3, 4, 5. 6 electrons. Okay, yes, what about chromium plus 3? Now, oxidation state ಹೇಳಿದೆ ನಿಮಗೆ plus 3. Plus 3 means loss of 3 electron. Chromium ಇಂದ 3 electron ಅನ್ನು ತೆಗಿಬೇಕು ನಾವು. ಹೇಗೆ ತೆಗಿತೀರಾ? Yes, argon 3d 4s. Okay ಪಾ, 3 electron ತೆಗಿಬೇಕಾದ್ರೆ ಫಸ್ಟ್ ಔಟರ್ ಮೋಸ್ಟ್ ಇಂದ ತೆಗಿತಾನೆ. ಸರ್ ಔಟರ್ ಮೋಸ್ಟ್ 1 ಇದೆ, ಹೋಗಿದೆ ಅಂದ್ರೆ 0. You have 5, 5 ಇದೆ, ಈ 1 ಹೋಗಿದೆ, 2 ತೆಗಿಬೇಕು. ಸರ್ ಹಾಗಾದ್ರೆ ಇದು 3d3. So now you have 1, 2, 3. Yes, there is no electron in s orbital. So it means n is equal to 3. ಬರ್ತಾಗಾದ್ರೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು ಎಲಿಮೆಂಟ್ ಆದ್ಮೇಲೆ ಅಯಾನಿಕ್ ಫಾರ್ಮ್ ಪ್ಲಸ್ ಎಷ್ಟು ಬರೆದಿರ್ತಾರೆ ಅಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನು ಮೈನಸ್ ಮಾಡಬೇಕು. ಸ್ಟಾರ್ಟ್ ವಿತ್ ಔಟರ್ ಮೋಸ್ಟ್ ಎಸ್ ಆರ್ಬಿಟಲ್. ಅಂದ್ರೆ ಪ್ಲಸ್ ಎಷ್ಟು ಬರೆದಿದ್ದಾನೆ ಎಸ್ ಹೊರಗಿಂದ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನು ಮೈನಸ್ ಮಾಡ್ತಾ ಬರ್ರಿ. ಬಾಕ್ಸ್ ಹಾಕೋರಿ, ಕ್ಯಾನ್ ಗೆಟ್ ಇಟ್ ಎನ್ ವ್ಯಾಲ್ಯೂ. ಇಫ್ ಯು ಗೆಟ್ ದಿ ಎನ್ ವ್ಯಾಲ್ಯೂ ಯು ಕ್ಯಾನ್ ಈಸಿಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ mu is equal to. Yes, you can use the mu is equal to square root of n into n plus 2. Square root of n into n plus 2. Yes, n is 3. You can use 3. Yes, this is a 3 plus 2. Careful ಆಗಿ ಮಾಡಿ ಮಕ್ಕಳೇ. mu. Yes, mu is equal to 3 plus 2 is a 5. 5 3s are 15. Root 15. Yes, what about the root 15 value? Yes, you can calculate with the help of calculator. ನಿಮ್ಮ ಹತ್ರ simple calculator ಇರ್ತದೆ. Yes, as I know, this is the value of your chromium plus 3. What is the magnetic moment value? Magnetic moment value of chromium is 3.73. If you get the fraction or you get the result, the compound is para. You know, this is a paramagnet. How to know my paramagnet? Because we have 3 unpaired. Due to 3 unpaired, it is an paramagnet. There is no unpaired electron, it is a paramagnet. This is a simple calculation of our syllabus. Magnetic moment is a formula mu, square root of n into n plus 2. Symbol is, notation unit is a Bohr magneton. Calculate ಮಾಡ್ತೀರಾ element ಅನ್ನು ಬರ್ಕೊಂಡು ಮಾಡಲಿಕ್ಕೆ ಬರುತ್ತೆ. This is a very simple one to calculate the chromium. If you want another one, ನಿಮಗೆ ಮತ್ತೊಂದು ಬೇಕಾದ್ರೆ ಇನ್ನೊಂದು ನಾನು ಹೇಳ್ತೇನೆ. Yes, we can take another example. So with the help of this you can calculate anything else. ನೀವು ಮತ್ತೆ ಬೇಕಾದ calculate ಮಾಡಬಹುದು ಮಕ್ಕಳೇ. I will show you another element mentioned in our syllabus, that is iron plus 2. Same question, calculate the mu value of iron plus 2. How to start? First, iron, atomic number 26, scandium, titanium, vanadium, chromium, manganese, iron 26, as electronic configuration argon 3d6, 4s 18, 20, 26. Okay, fine. Okay, how do you read the box? 1, 2, 3, 4, 5. This is a pair electron. It's 2 here. Yes, what about ionic form? Fe plus 2. Plus 2 andre loss of 2 electron. Ee 2 electron annu ತೆಗಿಬೇಕು ನಾವು. Yes sir. ಹಾಗಾದ್ರೆ argon 3d and 4s plus 2 ಹೇಳಿದಾನೆ, no problem. 0. This is as usual same 6. Okay, 6 stands for sir 1, 2, 3, 4, 5. This is 6. Yes, ಇಲ್ಲಿ ಯಾವುದು electron ಇಲ್ಲ. You can count 1, 2, 3, 4. Again, therefore n is equal to 4. 4 stands for it is a paramagnet. Paramagnetic. Yes, based on 4 you can calculate the mu. Mu is equal to, okay, yes, square root of n into n plus 2. So mu is equal to square root of n, 4 plus 2, simple. Mu is equal to 4 plus 2 is 6, 24. 4 plus 2 6, 6 4 so 24. Yes, the value is 4.90. Yes, you can easily calculate. Sorry, I know the values. So this is a 4.90. So this is a simple method to calculate your component. If you want to practice, apart from this, how can I practice? So you can practice the example Fe plus 3, scandium plus 2. Okay, you use chromium plus 2. Okay, and then you can use copper plus 1, copper plus 2, zinc if you want, especially zinc plus 2. Okay, can I use this one? Can I use this one? Okay, yes, I have to mention the example. Okay, once again, so it's very simple. You can use the calculation of Zn first. Do it fast. Yes, zinc, atomic number 13, argon. Okay, do it fast. 3d 10 and 4s 2. D orbital is 10. Yes, directly I will use n plus 2. This loss of 2 electrons. Argon 3d 10 and 4s 0. You can use a box. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, there is no unpaired electron. Therefore, n equal to 0. If n equal to 0, the compound is diamagnetic. Yes, there is no value. Mu is equal to square root of n into n plus 2. Yes, mu is equal to 0, 0 plus 2. We have the 0 value. Automatically the compound is diamagnetic. Yes, you can keep practicing with different elements with magnetic moment. Okay, thank you so much for watching. Yes, you keep practicing, friends. We will meet in the next video with the colors and complex. Thank you so much. Welcome to everyone. Today we move on to the next part of D block elements, the formation of colored ions. Dear friends, you keep in your mind that transition metals are always color in either liquid, means aqueous form, or either itself is in a solid form. Means transition metals always shows an color either in liquid and solid, except some metals like example zinc, mercury and some cadmiums. They are shows a maximum different variation of colors. Why these transition metals shows color? That is the major reason of our syllabus today. The transition metal shows color because they containing maximum number of unpaired electrons. This is the answer. Already we know every question having a single answer because of unpaired electron. Here also, why they form a color or shows color, the maximum number of unpaired electron. So dear friends, you keep in your mind, yes, the transition takes place in a d orbital, the lower energy to the higher energy within the d orbital. Within the d orbital, so always the energy gap is very less. ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ ಮಕ್ಕಳೇ, ಡಿ ಆರ್ಬಿಟಲ್ ನಲ್ಲೇ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ಲೋವರ್ ಎನರ್ಜಿಯಿಂದ ಹೈಯರ್ ಎನರ್ಜಿಗೆ ಜಂಪ್ ಆಗ್ತದೆ, ಎಕ್ಸೈಟೇಷನ್ ಆಗ್ತದೆ. At a certain time they start to emit radiations. Those radiations are visible in the visible region by using complementary color. Those shows different colors. ಅದರ ಯಾಕೆ ಕಲರ್ ತೋರಿಸ್ತದೆ ಅಂದ್ರೆ ಡಿ ಆರ್ಬಿಟಲ್ ಅಲ್ಲಿ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ಮ್ಯಾಕ್ಸಿಮಮ್ ಇರ್ತದೆ. Those electrons easily jump from lower energy to the higher energy. Why sir? The energy gap is minimum. The energy difference is minimum. ಇದು ಬಹಳ ಶಾರ್ಟ್ ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ this electron can easily shift from lower to the higher. Obviously at that moment the electrons emits the radiations, and those radiations are visible in the visible region with the complementation or complementary. They shows colors, friends. So I'll start with the example why how these transition metals, their ions shows different colors. A very interesting part, friends, is that a component is available is a scandium. Scandium can exist, I think all of you know, is in a +2 and +3 oxidation state. Scandium available +2 and +3 oxidation state. Yes, let us begin with the scandium. Atomic number is 21. Electronic configuration argon, 3d and 4s, 2 electron, and here it is a 1. S in d orbital, they have only one unpaired electron. S having 2 unpaired electrons. And due to this unpaired electron, keep in your mind, they can choose colors. Yes, therefore, scandium +2 means loss of these 2 electrons is electronic configuration argon, 3d1 and 4s2. Sorry, 4s0, not 2, 4s2. So now N stands for 1 unpaired electron. Due to 1 unpaired electron, they are colored. Unpaired electron idre makkale color ತೋರಿಸುತ್ತೆ. ಅದೇ ನೀವು ಸ್ಕ್ಯಾಂಡಿಯಂ +3 ತಗೊಂಡ್ರಿ ಅಂತ ತಿಳ್ಕೊಳ್ಳೋಣ. In scandium +3, argon, 3d and 4s, removal of all 3 electrons. This is also 0, this is also 0. N stands for 0. If N stands for 0, there is no unpaired electron. The component is colorless. Or certain cases they can use white also. Colorless means it's a white. We come to the conclusion is formation of colored ions is to removal of outer electrons with different oxidation state is easily available. We know the variable oxidation states. And in variable oxidation state, yes, +2 can of scandium shows color because the shows 1 unpaired electron. Yes, scandium +3 can shows 0 unpaired electron. It is colorless. This is the simple concept of coloration of the transition metal. In as our syllabus then mentioned the 2 questions. Why copper +2? Why copper +2 is color or colorless? You can find us answer. Copper +2 is color. Copper +1 is colorless. This is why copper +2 is color, copper +1 is colorless. We know the answer, friends. Copper is 29, argon 3d10 and 4s1. Copper plus 1 stands for loss of 1 electron. So argon 3d10 and 4s0. Therefore, n is equal to 0. There is no unpaired electron here. N equal to 0. This is colorless. Banna illa sir. If you consider the copper plus 2, argon will remove the 2 electrons. 0 here it becomes to 9. 9 stands for 1 unpaired electron. 9 ಆದರೆ 1 unpaired ಇರುತ್ತದೆ. Therefore, yes, n equal to 1. Yes, so it is color, especially it is a blue color. And this is also an answer. Scandium, you consider in a copper. If you want to take another best example of our syllabus is zinc friends. So many times they ask this question, why Zn plus 2, zinc plus 2 is colorless? Very simple, the same. Zinc atomic form is 30. If you use 30, argon 3d10 and 4s2. Plus 2 stands for loss of 2 electrons. Argon 3d10 and 4s0. D10 system. Due to this reason, D10 n is equal to 0. If n equal to 0, the compound is colorless. This is very important for 2 marks. If this question will ask for 1 mark, if I have so many in competitive exam, direct answer, yes, you can use, yes, why zinc plus 2 is colorless? Because the reason is D10 system. ಏನು ಬರೀತೀರಾ? ಯಾಕೆ zinc plus 2 colorless ಇರ್ತದೆ ಅಂದ್ರೆ ಸರ್, it is having a D10 system. ಇಲ್ಲಿ ಬರುತ್ತೆ ಮಕ್ಕಳೇ, ಸರ್ copper 1 and copper 2. Sir, why copper 1 is colorless? Because this is D10 system. Sorry, D10 system. Copper 1 is D10 system. Why this is a color? Because it is a D9 system. And this is the major concept of color of transition metal. I repeat friends, why transition metal form the colors? Transition metal itself is a color either in liquid medium or either aqueous medium or either in solid medium, because they contain maximum number of unpaired electrons. Those unpaired electrons can undergo excitation from lower energy to the higher energy of the same d orbital. Than orbital alle tanu excitation ಆಗ್ತಿರ್ತದೆ ಮಕ್ಕಳೇ, and due to this time they emits the radiation that can visible in visible region with different colors. Keep in your mind final conclusion, d block ಎಲಿಮೆಂಟ್ಗಳು ಏಕೆ ಬಣ್ಣಗಳನ್ನು ಕೊಡುತ್ತವೆ ಅಥವಾ ಅಯಾನ್ಗಳು ಏಕೆ ಬಣ್ಣಗಳನ್ನು ಕೊಡುತ್ತವೆ? ನಮ್ಮ ಉತ್ತರ ಫಿಕ್ಸ್ ಅದ, because of unpaired electrons. As maximum number of unpaired electron, the color sharpness becomes to the maximum. ಎಷ್ಟು ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಗಳನ್ನು ಕೊಡ್ತೀರಾ ಅಷ್ಟು ಶಾರ್ಪ್ ಕಲರ್ ಬರ್ತದೆ. ಈಗ ಎಕ್ಸಾಂಪಲ್ ಹೋದ್ರೆ ಮ್ಯಾಂಗನಸ್ ಪ್ಲಸ್ 2, Mn plus 2 ದಲ್ಲಿ ನೋಡಿ 5 unpaired electron, it becomes a very highest purple color. So this is the very interesting question in annual examination. I will give the question also, why copper 1, copper 2, why zinc, why scandium, or it shows the colors or colorless. You keep practicing with the different example. Yes, the answer you keep in your mind. If you get the n values is a number, is becomes to the color, n values becomes to the 0 is colorless. Okay, and in the next video friends, we move on to the next bit of our syllabus, why d block or transition elements are good catalysts or either they form a good complex formation. Okay, thank you so much for watching.